Good afternoon. Welcome to the Embedded Executive Podcast. I'm Rich Nass with Embedded Computing Design. This week our guest is an old friend of mine, Steve Hanna, a distinguished engineer from Infineon. How are you today, Steve?
I'm doing great, Rich. Thanks for
That's
having
good.
me.
My pleasure. Well, I had you because you scared the you-know-what out of me the other day over lunch. So I said, why don't we just scare the whole world with this topic? And the topic is, let me get this right. The growing cybersecurity risk of artificial intelligence and what can be done about it. So you and I had this discussion over lunch about how this is a really scary time, and we need to stay ahead of the bad guys when it comes to AI. But it's way more involved than that. So I'd love for you just to go through it the way you went through it for me over lunch, and let's just talk through this again.
Absolutely. So we've known for some time that these large language models, the same ones that we use in ChatGPT and Copilot, that they have growing capabilities in coding and in analyzing code, which is a wonderful thing. It allows software developers to be so much more productive. But there's a bit of a shadow side to that, in that when they analyze code, or a code base, as a group of software is considered called, they can find vulnerabilities in that code. And they can even chain together those vulnerabilities into what are called exploits, which is basically the ability to, say, achieve some goal with respect to the software, such as running an arbitrary command or getting admin or super user privilege on a particular system. So these cybersecurity offense capabilities of the large language models have been increasing at an exponential rate. And the latest data shows that today's frontier models, the real cutting edge ones, Claude Mythos and GPT 5.5, can, if they're properly configured with the right tools and harnesses, achieve cybersecurity offense capabilities equivalent to those of skilled cybersecurity experts. And that has some real serious implications for the security of our software and the things that we depend upon
But let me
in our
interrupt you here,
world.
Steve.
Yeah.
99.9% of what you're talking about is using this technology for good. And that's why it is being pushed to the extent that it is, right?
Yes. Yes,
Okay,
that's
I just
right.
want to be clear on that. Okay.
The folks who are building these models are not building them to be used for malicious purposes. In fact, they've put on handcuffs on the models that most people have access to make sure that they're not used to find those vulnerabilities and build those chains of vulnerabilities into exploits. The thing is that the bad guys can get their hands on these models, or the attackers, shall we say, can get their hands on these models without the handcuffs. One of the ways that that happens is that researchers have shown that open source, or as they're called, open weight large language models, can achieve comparable results. So these are things that that they can't handcuff because they're effectively open to anyone. And we can assume that the militaries of all of our major nations that have a cyber arm to the military, which is effectively all of them these days, have access to similar capabilities. And it's not just the military, but we have to assume that the criminal rings and organized crime will get their hands on them as well. So let's look at the bright side, though, as you pointed out. Not only are these models useful in vibe coding, as they call it, using these models to write lots of code, but the cybersecurity defenders can use the models to find vulnerabilities in their own code and then to create patches for those vulnerabilities and integrate those patches. So this is what's been happening for the last couple of months. People have surely heard of Project Glasswing or of Claude Mythos itself. Uh, uh, Anthropic, who makes Claude, has restricted access to Claude Mythos for a few months to what they view as critically sensitive companies. Only those companies get access to Claude Mythos. They're part of this project Glasswing. And they've been using Claude Mythos to find vulnerabilities in their own code. So Microsoft, Google, Amazon, uh, and Cisco and others have been looking for vulnerabilities, finding vulnerabilities, patching those vulnerabilities at a frenetic pace for the last few months to make sure that when these frontier models get out there and the attackers get their hands on them, that already many of the vulnerabilities, at least the most serious ones, will have been found and fixed. That's certainly the hope. And some open source groups, well, for example, Red Hat Linux and Linux Foundation are also able to get their hands on it. Not everybody. I mean, the number of software developers and companies that make software or software as a service is much bigger than they can accommodate in this project Glasswing, but they are gradually opening the program to more companies that make software, and those companies are using the tools to find their own vulnerabilities and get them patched, we hope, before the attackers can find the vulnerabilities. But it points out the importance of installing those updates as soon as they become available, because if Microsoft releases a set of patches, for example, for Windows, within certainly a few days, those patches will be reverse engineered and the attackers will figure out how to exploit them. So you have to get your patches installed right quick now. And there will be and are being more and more and more patches coming out because of this superpowered and supercharged capability for finding vulnerabilities.
So let's go back to the idea of the handcuffs. What exactly does that mean? And are we trusting the people who are putting them in place?
Well, I'm happy to say that both Anthropic and OpenAI have cybersecurity teams, and it was they who pointed out this uh, tremendous increase in the capability of the models, nonlinear increase in the capabilities of the models. So they're the ones who designed the handcuffs based on their experience using the models. And the handcuffs might, for example, restrict the set of requests that you could make to Anthropic, to Claude, if you're with Anthropic, or GPT 5.5. And if you make an illegal or an unauthorized request, one that's restricted by those handcuffs, for example, here's a bunch of source code, please find those vulnerabilities for me, and you're not part of Project Glasswing, then they're going to deny your request. Now, it is possible for the AI to sometimes be tricked into avoiding those constraints. We've seen that over and over again with clever prompt engineering. You can sometimes get the AI to do things that it was programmed not to do. So I wouldn't regard this as being a bulletproof protection against cyber attackers using their models, these models, commercially available models, for finding vulnerabilities. I do expect that we will see, especially with companies who are not part of Project Glasswing and therefore don't get that early access, that we'll see a an arms race, so to speak, between the good guys and the bad guys, trying to find the vulnerabilities before they can be exploited.
But that was my point exactly. That we've agreed that it's impossible to write code that does not have any vulnerabilities. Isn't it just a
Mhm.
matter of time before they get exploited?
Well, that's always been the case, Rich. What's changed here, it's always been the case, as you point out, that the software has vulnerabilities and that they can be exploited, and the bad guys look for them, the good guys do as well. What's changed is the pace. Just crank it all up by a factor of 10 or more.
On both
Because
sides?
on both sides, yes. Both sides, so long as they have the ability to buy the tokens uh, and use the AIs, they have the ability to increase the rate at which they can find those vulnerabilities, because you don't have to have a cybersecurity expert any longer in order to find them. And yes, there is some so-called AI slop or hallucination or just error on the part of the AI, where some of its uh, vulnerabilities will turn out to be not very serious, or maybe not vulnerabilities at all. But the AI can be used. You can set up one AI against another to filter out um, that slop. So yeah, both sides are really cranking now, um, cooking with gas, as they say.
So is the best method here just keep your fingers crossed?
No, I would say for anyone who develops software, you need to uh, do everything you can to start using AI and learning how to use AI to find vulnerabilities in your software. And you need to talk with your suppliers, because most of us use tools and libraries to make our software work, whether that's a security library like OpenSSL or a graphics library, whatever, to make sure that they are also cranking up using this turbo power, so to speak, to crank up their uh, ability to find vulnerabilities and get them patched, and then to make sure that those patched version of the libraries gets included in and built into your software offerings right away. But there is an action for consumers here as well. It's not all about the companies that make the software products or the hardware products, because of course hardware these days has a significant software component. There's also an element of consumer responsibility as well, that, as I mentioned earlier, the consumers have to install those patches ASAP. And if the consumer or the customer, if it's a commercial or industrial customer or a government customer, if they don't have the ability to quickly install those patches, they need to change their assessment of the risk that constitutes to their organization or enterprise. They have to realize that the risk is considerably greater now. There are, at least there will be for the next few years, uh, much more rapid, many more vulnerabilities coming much more rapidly. And if you can't patch things, you need to take them offline, so that they can't be remotely exploited. Put them behind an air gap if you can, or at least behind a careful DMZ set of firewalls to protect them from external attack. That may not be completely effective, but you really need to be upping your game from a defensive standpoint.
Yeah, that's what I was thinking. The best way to defend yourself is just unplug, go back to paper and pencil, and then you won't get exploited.
The UK's government's cybersecurity agency actually recommended last fall to their businesses that they have a backup plan where they could go back to paper and pencil, because they have several of their major supermarket chains that got attacked, and Jaguar Land Rover also had its factories down for more than a month because of cybersecurity attacks. So they said, You have to have on hand what you need to be able to do your job and to keep your enterprise up and running if everything goes sideways and you do have to fall back to a a manual process. Well, when I talk with customers, I tell them the same thing. Of course, for most of us, that's pretty hard to imagine, but you know, uh, um, having some sort of a backup plan if your systems or the services upon which you depend are unavailable, you know, it it it's a good fallback, so you're not out of luck if that should
Imagine that,
happen.
having to turn the lights on and off by hand and having to open the blinds by hand. Oh my God, I don't know if I could do that again.
Well, Rich, you're in luck in a way because when we built the Matter standard for smart home, we built it based on a zero trust architecture. The idea that we knew that some of the things in your house were going to get infected, and that we wanted to minimize the impact if that did happen. So, for example, the light bulbs in your house only get the privileges that they need, which is very little. So if they do become compromised, then the harm that they can cause is very low within your house. Now, that being said, that's smart home. I guess the worst case scenario is you have to unplug things to turn them on and plug them to turn them back on, to turn them off and on. But we need to look at other more serious things as well, such as industrial equipment, um, critical infrastructure, and make sure that that's adequately protected. I think that's one of the reasons that the Trump administration, in their new executive order on AI, required that or set up a structure by which critical infrastructure providers could be informed rapidly of cybersecurity issues as they emerge, and required review of new AI models to see what their cybersecurity implications are.
Very, very interesting, Steve. And I think this is just the beginning of the series that we're going to be doing on this topic as we go along. I do appreciate all the work that you've put in to make this work and for helping educate me.
Yes, I'm happy to do so, and I'm hopeful. I am an optimist. I know it's going to be a stormy few years, but I am hopeful that in another 5 years, all of the software is going to be just so much more robust because of the hailstorm of vulnerabilities that will have been coming at it and the many patches that will have been put in place. So, in the end, we may well come out in a better place from a cybersecurity perspective.
Very good. That was Steve Hanna. He is a distinguished engineer with Infineon, and I am Rich Nass with Embedded Computing Design.